There we have it. Yes, welcome, ladies and gentlemen. This is about the Giantleap Project. It's a EU project based on hydrogen and hybrid hydrogen battery buses. So, let's see if we can get it to work. Can you skip to the next slide, please? Yeah, that's for the outline, a bit of introduction motivation, then we'll go through the various results in the project. Okay, here the motivation is mainly that we have still a very high cost for fuel cells today. It's in the range of 1,000 to 2,000 euros per kilowatt if you buy them today. But we expect a breakthrough if we go into the hundreds, for example, less than 300. That's a graph from the Department of Energy in the US, and that indicates the most important takeaway is that the price will be reduced mostly by mass manufacturing rather than technological improvements in the next few years. So what we're waiting is for mass manufacturing. And there is also, you might have noticed around here, there is a shift in interest from personal cars to heavy duty. Buses, trucks, ships, you name it. And the operators of this kind of vehicles are more interested in TCO, in OPEX, CAPEX, and lifetime, rather than for the car being cool, like a Tesla buyer could be. So, of these, lifetime is definitely the most uncertain. In the SHIC project, you might have heard of it. It was a very big EU project, over 80 million euros in budget. They measured a very low availability. It was in 70%. Now there are a cluster of other projects on buses in Aberdeen. They measured more than 85%, but it's still a far cry for an 88% that you need in buses. Like that's what you get from diesel. You need reliability, and most of the time these buses did not have problems with the fuel cell stack itself. It was mostly the balance of plant, other problems, for example, supply chain. And that's why we started this project Giantleap to solve all these problems, to increase availability and to make hydrogen buses more acceptable to bus operators. So our concept is we're going to have a battery bus with a hydrogen range extender. We'll employ online diagnostic tools and apply prognostics to determine how long the system is going to live. So for the hydrogen relay, that's what it looks in a CAD drawing. It can be connected and disconnected by operators. There is no need for special technicians. There are only 3 connectors: mechanical, power, and communications. And this way you can have a flexible bus fleet. You're all battery buses, and when you need a long range or you need don't have the time for a charge, you just connect a hydrogen range extender like this one, and off you go. Then you can make a city bus into a regional bus. You can also use it to charge cars in theory because it follows a very standard CCS protocol. It has 2 stack modules by Giantleap for a total of 76 kilowatts nominal. And the balance of plant system was developed by Bosch. There were a number of bureaucratic implications whether this is a battery or a hydrogen bus. I won't go into that, but it was quite interesting. Several people may know about electrochemical impedance spectroscopy. That's a very important tool for diagnostic of fuel cell. And in this particular case, you can see there is a little curl at the end on the right side. That's a low frequency curl. And it is not something we discovered. It's you find it in the literature. But our project partners in University of Split in Croatia found out that that resistance on the right, R4, is a very good prognostic variable. And this way, if you can find that one, you can tell how worn the fuel cell is. However, that resistance is in parallel with inductance, so you cannot measure that when it's at steady state. You need impedance spectroscopy or something else dynamically. And that's what we did. We applied relay feedback. This is what we did in SINTEF. Relay feedback is an old, very old technique from the 50s for tuning of PID controllers, and we modified that to work with fuel cells, and it actually worked wonders. We tested that at Erin Klinger in Dettingen and the Arms, and this actually was able to measure this value of impedance that we're interested in within a few seconds. I'm talking about 10 to 20 seconds for convergence time, with equipment that cost in a total 130 euros, and that we actually bought at an electronics store in Stuttgart. So it is available. So very commercial stuff. Volta rejuvenation is a phenomenon we first observed in a previous project we actually presented here in Hanover 3 years ago, Sapphire. Long story short, we noticed that when a system was restarted and shut down and restarted again according to a specific procedure, the voltage actually kept creeping up instead of down as we expected. As you can see, the voltage from such a system is very erratic. It's very difficult to say anything about degradation rate until you have tested for about 1,000 hours. But we managed to reproduce this effect in control conditions. So we know that it is possible to rejuvenate a fuel cell to a degree. And we start understanding this process. There is a report that is available on giantleap.eu. Our website is public and free for all. And we study systematically on Ehring cells how this phenomena could work. We have now a number of pointers of how we can induce this phenomenon. We have not yet quite understood exactly what is the physical reality is. We have some pointers. It could be accumulation of oxygen or accumulation of water in the cell or in the membrane. We have some ideas, but this is actually something, a very exciting topic of research we are still working on. But we know enough that we can implement this on the system. Balance of plant, I mentioned before, it's really important because it's the main cause of failures in the systems, especially the compressors, supply chain as well. And in order to avoid a problem supply chain, we tested here what is a Rotrex, very standard automotive compressor with a fuel cell system. We want to use standard components so that we don't have problem with supply chain. But this specific compressor, after being tested, failed after 200 hours. And of course, we cannot have that. That's not good enough. And so we have a public report on the experiments on this compressor and on humidifiers and other BOP components that is also available on our website and for you to peruse. So why did a compressor break after 200 hours? Well, it was connected to a stack cathode inlet, of course, so it was pushing air into the stack, and it had a different characteristic compared to the normal internal combustion engines it was working with. And it turned out that while the nominal operating point was within the normal envelope, you can see there circled in red and blue, there are a number of areas that are beyond the surge line, and those are the transients. So if you measure during normal operation, everything looks good, everything's fine, but during transients you have this operation beyond the surge line that over a few hundred hours is going to wear the compressor. So in the case of Bosch, they found a very simple solution. So they added a bypass valve, and now it works. Of course, the real solution will be to develop specific components for fuel cell systems. This is not especially efficient, but again, supply chain is more important at this point. Vibrational sensor, we tested that, but it only gives a very short warning, about 3 hours. So it's really important to make sure you do not operate in those conditions. Humidifier, it has quite fast degradation in the first 100 hours, but fortunately it settles down to a certain level. And given the data that has been obtained by Bosch, we can also use that number to dimension the humidifier so that we don't need to exchange it at a later point. Also, all this data, I'd like to stress, this data will be made public on our website. They are not yet. We have to make sure there is nothing confidential in there, but it has been very difficult to find data for balance of plant components in fuel cell systems, and we want to fix that, and that will be free for all to use. Prognostics, this is for fuel cells. It will be extended to fuel cell systems by the end of the project, which is in October. This is for a fuel cell stack, and we can tell that the Ehring stack is able to meet the target of 12,000 hours we had for this project. In particular, this stack has lifetime is estimated at 15,200 hours, which is more than good enough. It's an automotive-derived, it's a car-derived stack. so it's not a specific bus stack. One thing that we noticed is that fuel cell control units are not particularly computationally powerful. They must be reliable. That's the first thing, because you cannot afford to have a crash in a fuel cell control unit or in a vehicle control unit. Otherwise, that gives the word crash a more concrete meaning. So one thing that we can do is to have some of diagnostic on board, but the heavy prognostic should be done offline. So we could upload the data to the cloud, maybe collate all the data from multiple buses or bus fleets and sell prognostics as a service to bus operators. Yep, next. So in conclusion, the key to industry acceptance of hydrogen buses is reliability, and that's the same for hydrogen trucks and hydrogen heavy-duty applications. We have a possibility to have a very strong flexibility with the hydrogen range extenders instead of pure hydrogen buses. We applied relay feedback and very old control techniques in order to produce novel diagnostic tools. We have proven that you can recover some of the degradation from fuel cells, but still we need more attention to balance of plant. That is absolutely critical. And according to Prognostics, for now we can tell that the fuel cells will last long enough, and the question now is to work on the balance of plant. So, thank you very much for your attention.
Thank you very much, Dr. Federico Zenith. Are there any questions from the audience right now? Okay, so you said the project will be finished in October, September?
It will be. And right now we are working on a demonstration. So that system is being built. Right now it's in Abstadt at Bosch. It's been equipped with the last bells and whistles. Then it will be sent to VDL in the Netherlands, where it will be then, we got its wheels, and then we will have it tested on road.
Okay. And so what's after the project is finished? You mentioned prediction as a service, for example. This will continue with one of your partner or within the Giantleap project?
Yes, Prognostics is developed by a University of Franche-Comté in France. So they are more interested in the science rather than the commercialization. But of course, if somebody wants to buy the software, we are at booth D74. And, well, come along.
Okay. Thank you very much again. Please give a big hand of applause for Dr. Federico Zenith.
Thank you.